Hello everyone, let's welcome to my channel. So here we are going to discuss one more question based on ordinary differential equation. The topic is system of linear order differential equation. So here the critical point of the system dx by dt equal to minus 4x minus y and dy by dt equal to x minus 2y is n. So here the system of differential equation they have given you, that is a dx by dt and dy by dt. Then I have to check what will be the critical point of this differential system of differential equation, whether it is stable or not, stable or unstable. If it is stable, which type of stable it is. So to find out or to check, whenever the system of linear differential equation is given to you, you can easily find out the critical point. So to find out the critical point, I have to write this system of linear differential equation in the form of y dash equal to ay. So y dash will be your dx by dt and dy by dt, and a will be your matrix, the coefficient of your x and y, and the y will be your variables, that is x and y. So write these two equations in the form of matrix dx by dt, dy by dt, that is equal to minus 4, 1. Minus 4 will be the coefficient of your x for the first equation, and minus 1 will be the coefficient of your y, and 1 minus 2. 1 will be the coefficient of your x, and this minus 2 is the coefficient of your y, and the xy will be. If you multiply both the matrix, again you will get the same thing. Okay, the first thing is, whenever the linear or system of ordinary differential equation they have given you, you have to write in the form of matrix. Then I have to find out the eigenvalue of the matrix. So here you got 2 cross 2 matrix. Here I got the 2 cross 2 matrix, that is minus 4 and minus 1, 1 and minus 2. So here I got the 2 cross 2 matrix. So I have to find out the eigenvalue of this matrix. So what is the standard formula of, what is the standard characteristic equation for your second order matrix? That is lambda square minus trace of the matrix A into lambda plus determinant of A, right? So what is the trace of the matrix A? That is sum of the diagonal elements. Sum will be minus 4 plus minus 3, it will be minus 6. So lambda square minus will be as it is minus 6 lambda plus determinant. What will be the determinant? 4 into minus 2, it will be 8. 8 minus of minus 5, it will be plus 9. So here the characteristic equation will become lambda square 6 lambda plus 9 equal to 0. Now factorize the 6 lambda, it will become lambda square plus 3 lambda plus 3 lambda plus 9. So you are going to get that as a lambda plus 3 and lambda plus 3 equal to 0. Okay. So if you equate it, what you are going to get? You are going to get the eigenvalue, that is a minus 3 and minus 3. It means here I got the repeated eigenvalues, but they are real. Eigenvalues are real and they are negative also, and they are getting repeated, right? So there is a property to define which type of stable it is or which type of unstable it is. So whenever the eigenvalue are equal and they are negative, stability of that will be asymptotically stable, and the nature will be your node. Okay, so which option is going to correct? Stability of the critical point, it is stable, and nature will be node. So the option A will be correct. This is option C is also stable, but it is a nature of that eigenvalue is spiral. But here whenever the eigenvalue is negative and they are equal, the nature of the eigenvalue is going to be node. So option A is correct. Let's see one more question based on critical point so that you can get the clarity about that. So here the question is, the critical point of the system dx by dt equal to 2x minus 7y, dy by dt equal to 3x minus 8y is there, and we have to check whether it is stable or unstable. And if it is stable, at what point it is stable, what is the nature of that, whether it is a node or spiral. If it is unstable, it is whether it is a node or a spiral. So the first thing for the critical point of the system, what we have to do, we have to write the given equation in the form of matrix. So it will become dx by dt equal to coefficient of x is 2, coefficient of your y is minus 7, and coefficient of your x in this equation is 3, and the coefficient of your y is minus 8. So x and y will be as it is. If you multiply both the matrices, again you will get the same. So we know that. So how to Again we have to find out. Here we got that this is your A matrix and this is your Y. Okay, so A is your matrix which contain which is of order 2 cross 2, that is 2, -7, 3 and -8. It is of order 2 cross 2, and we know how to find out the characteristic equation. The characteristic equation will be lambda square minus trace of the matrix A into lambda plus determinant of A equal to 0. So characteristic equation. So 2 trace of the matrix. Trace of the matrix is nothing but a sum of the diagonal element. Sum of the diagonal elements will be 2 plus of -8, it will be 6. So here we are going to get lambda square minus of -6 plus lambda. Determinant of A will be 2 into my 8 minus 8, it will be -16 and plus 21. Here we have a -7 into 3, it will plus 21, its value is going to be 5. So determinant will be 5. So here you are going to get the characteristic equation has a lambda square plus 6 lambda plus 5 equal to 0. Again factorize it, you will going to get it as a lambda plus 1 into lambda plus 5 equal to 0. So eigenvalues will be -1 and -5. So in this case the eigenvalues are not getting repeated but they are negative. So here lambda 1 value is -1 and lambda 2 is -5. In the previous question we have seen that eigenvalues are same. If eigenvalues are same and they are negative, in that case you are going to get the stable and the node. So here the eigenvalues are real, distinct and they are negative. So let's see the another property. Whenever eigenvalues are different and their product is getting positive, okay, if your eigenvalues are different but their product is getting positive and each eigenvalue is negative, then critical point of this linear system is going to be stable and nature will be your node. They are going to be stable and its nature is going to be same. So product minus product of the eigenvalue, lambda 1 is -1, lambda 2 is -5. If you multiply both, you will get the positive. So that here the lambda 1 value is -1, lambda 2 is -5. Both are negative. The first thing, if they are both are negative and they are different, then you have to check whether they are getting multiplied. If they are getting multiplied, whether it is positive or negative. If it is positive, -1 into -5, it is going to be stable. Okay, the first, so it will be stable and the nature of the critical point is going to be node. So option A is correct.